This podcast supports fumigators in improving safety, compliance, and solutions. Always follow the federal fumigant label, state and local laws. Licensed fumigators are legally responsible for their applications. And now, on to All Things Fumigation. Out here, we don't just fight pests. We outsmart them. This is All Things Fumigation, where applied science meets real-world grit. I'm John B. Mueller, a fumigator by trade, and your guide to the science of fumigation done right. Each month, we saddle up with the people, the practices, and the precision it takes to keep facilities safe, compliant, and pest-free. Because when you're in the trenches of pest control, you don't need magic, you need science, and maybe a little cowboy spirit. Smarter solutions, safer practices, managed costs. Welcome to All Things Fumigation. All right, welcome to another episode of All Things Fumigation. This is episode 10, and it's in the series of the fumigation process. And that point we're at right now is fumigation ventilation and clearance. And we always try to have a theme for each episode, and this one is blow like the wind. And it just seemed to be appropriate for a fumigation ventilation talk. And I really appreciate the viewer questions that have been coming in. There's been some really good ones. I continue to collect those. This one I selected because it was based on our last episode, which was episode 9, on monitoring, fumigant monitoring, efficacy monitoring. And it's from an anonymous fumigator. They asked that I not use their name, but the quote from their email was, we want remote monitoring systems in our company. We just can't get leadership to approve the upfront cost of purchasing connected devices. How can we convince them these are savings and not costs? And I think, first of all, this is a great question. I think it's where we're at right now in the whole process. There's a lot of energy around connected devices right now. Some of it is being driven by Australian Department of Agriculture, DAF. That's kind of moving into USDA has a couple of projects going on right now on connected devices. And then I think both commodity managers and food safety managers are starting to ask deeper questions about validation of these fumigations. And so we beat this up quite a bit. We're going to have more on this in LinkedIn and on the website, thefumco.com, because we want to help people understand how to bridge this. Of course, there's an upfront cost, but there is a very rapid return on investment. And if you think for a moment, I've got a graph up for those that are watching. For those that are listening, I can easily describe this to you. Generally, let's say we're doing an average sulfuryl fluoride fumigation of 100,000 cubic feet. We generally will take gas readings, usually 2 or 3 in the first 12 hours. And in many instances, we're plugging that we should be plugging that information into the Fumiguide, and that Fumiguide will direct us whether we're on track or not. And the reality of a lot of fumigations are that we have to add some gas back at those intervals. And interestingly, if you can visualize this, we're not capturing the peaks of the introduction of the gas. The initial introduction, if we're only taking a reading at the 3 or 4 hour mark, we completely miss the CT that's accumulated to that point. And then that skews the information and the feedback that we're getting from the Fumiguide program. And it's directing us to add gas in some instances, many instances, when we don't need to. And in general, and I've looked through a lot of data, a lot of continuous monitoring data, And in general, I'm finding between 5 and 10% fumigant cost savings with every fumigation. And that directly goes to that return on investment. So, in this instance, 100,000 cubic feet, that was around $360 to $400. So depending on how much you're fumigating, you can see how you can pay that back very quickly. In 2013, when we couldn't afford to invest in connected technology, we did for scaling purposes. And I think on the third fumigation, it was a large fumigation, we saved $5,000 in gas cost efficiencies. And it woke us up, and we really started to watch this more closely. So don't want to go too deep into that. There's more to come on this. There's hard cost savings. There's a lot of soft cost savings like protecting reputation and providing validation to customers and more. So we want to get into fumigant ventilation and clearance, and we're going to start with that fumigation process, kind of linear tile that you've seen before. And that process is planning, prep, setup, gas application, gas analysis, and now we're on clearance. And we want to just stop for a minute and focus on clearance like we have the other segments. And, in this step, of the fumigation process, this clearance could pose the biggest safety risk of any of these segments. And let's kind of step back a little bit and just really look at it from kind of above. When we go in to activate ventilation systems, we usually have to suit up in an SCBA, or always have to suit up in an SCBA if we go in to turn these vents on, and we're walking into an IDLH atmosphere. IDLH is a safety acronym. It stands for instant danger to life and health. And that's why we have to wear either a gas mask or an SCBA to activate these ventilation systems. Now, in some instances that when we're fumigating, like containers or most grain fumigation scenarios, that's not usually the case. But in milling operations and food processing operations and warehousing operations, it's almost always the case. There's other issues around unsealing when you send your crew to the roof or to put their face in front of a vent to cut or remove plastic seals. We have gas coming out on our team members. So that has to be reviewed, and we've got safety implications there with personal monitoring. And then the release of gas from a structure, and this is for all fumigations. There's a risk to bystander safety, and right now that's really something US EPA in some of these fumigant re-registrations has been keying on, is how are we protecting the community when we start these ventilation processes. So we're gonna address those as we move through. This episode is going to deal a lot more with some of the basic foundations, but also tips and considerations. Some of these you may be very aware of. Some may be good brain candy even to consider. So ventilation and clearance, that first step is unsealing, right? So with personal safety gear, we remove those seals, but it's always key to not spend too much time on those roofs. We need to cut those seals. We don't have to remove, all the tape and everything that we put behind. We eventually do, but in the first phase, it's just getting these vents so that we can activate them. And then we release that gas at a pace that's representative of the situation that we're dealing with. If we've got neighbors close by, businesses close by, residential communities close by, it's wise to start ventilation slowly and monitor those fence lines, very careful for adulterative gas levels. And if we see levels that are concerning, we've got to trim that those ventilation systems back a little bit. So the unsealing process is something that has to be planned in advance. I think it becomes a byproduct of the fumigation, and oh, by the way, we've got to vent this now, and just go and start blasting everything and turning everything on, and in many instances, that's not the prudent step, right? From a tip standpoint on unsealing, one of the rules I always lived by is whoever seals it has to unseal it. So I am seeing scenarios, and I've done some autopsies on some fumigation mishaps, and it is critical that whoever seals it unseals it, because when you have a crew that comes in and prepares a fumigation and seals, and then a different group of people that come in and unseal, it's the worst Easter egg hunt in the world trying to find those seals. And if one is missed, it could turn into that $1 million seal that precipitates an insurance claim. It could lead to product contamination. It could lead to startup delays because systems, piping collapsed and systems won't start up now. So it's very, very important. If you are having new people come in, they need to be tagged with people that are aware of what's been sealed. There needs to be a good standard operating procedure identifying where all these seals are. It seems basic, but it seems that our industry continues to have mishaps in this space. And then, again, whatever we put down, we've got to remove and throw away. So it doesn't all have to be done at once, but after the ventilation system has started to subside, we're getting clean air coming through those vents. It's safe to work on that roof now, unprotected. You still keep a personal monitoring device with you, but you go up and you do the final removal of sealing material. And I just want to say it again, it can't be said enough, beware of those $1 million seals. Those seals that, if they're not removed, it's going to cause significant pain points. I want to go into some terms. I think in our industry, we talk a lot about aeration, and it's always been a little bit of a pet peeve of mine. What we're doing is ventilating. If you look at the definition of these two, it may seem trivial, but I think it's important, especially when we're communicating with customers and other people in terms of vernacular. Ventilation is the process of exchanging stale indoor air with fresh outdoor air to improve air quality, remove pollutants, and regulate humidity. That's what we're doing, right? Not the humidity part, but everything else. Aeration is the process of circulating, mixing, or dissolving air into a substance. So not what we're doing. So ventilation is really the term that we want to follow, so we're not creating confusion. The process, basic process, right? It's the termination of a fumigation by the initiation of a ventilation. So lots of shuns. We then monitor the decline in gas concentration, and then we adjust airflow as needed. We adjust airflow based on potential fence line readings, but also as we watch the structure that we're ventilating, is the gas coming down in a uniform way, or do we have areas where gas is hung up and it's very slow to degas and ventilate? So we might have to make adjustments there, and we're going to give some tips and some insights to that. There's another term that I think is important, is passive ventilation versus active ventilation. Great example of passive ventilation is land sea containers. Many times we don't feel like we have the tools to hook up active ventilation. Even if we stick a fan in front of the open door of a land sea container and blow air in, it's somewhat active, but we're still getting kind of passive degassing of that statically dense material. And many times people are just opening the doors of the containers and just letting it passively vent. So in most other instances, passive ventilation is not an issue. And then there's clearance versus gas-free. They're essentially one and the same. Clearance is more of the final process of ventilation. And then we refer to, things like documents like a gas-free certificate, where we certify that the facility has been cleared and safe levels have been achieved. And it's a very important document that we're going to touch base a little bit more on later. And then one important point that I'm not sure is discussed a lot is safe breathing zone. I think sometimes there's confusion around what it is that we have to clear. And at the end of the day, it's the breathing zone. Many times we'll try to monitor some of the statically dense material to try to get an indication of how it's coming down. But at the very end of it all, we have to make sure that all breathing zones are safe. And here you look at a graph, and I'll describe it for listeners. It's one thing that I've shown over and over again as really the perfect fumigation, a very mature fumigation that's been honed, over several treatments. But what you'll notice in the beginning of this fumigation is there's a lag in in one of the gas readings, and that's monitoring inside statically dense material that's being treated. The rest of the lines are all together in the free space, and they're nice and tight. But there's about a 4-hour lag in penetrating that material. And it's important to understand that because it takes an additional 4 hours in this scenario on the front end of the fumigation to get gas where those insects are. But on the back end, there's also a lag getting out of that dense material. And this is extremely variable depending on the density of the product and the packaging material and things like that might be, in each setting. But we have to observe that because if we've still got gas in dense material and we stop that ventilation too soon, then we can have gas readulterate that space. So we do have to pay attention to dense material. And then a ventilation plan should be developed before the fumigation. I see this a lot. Again, it's sometimes treated like a byproduct of the treatment, but it's part of the treatment. And it should be part of your overall plan. You need to know in advance where to activate these ventilation systems, where are the switches, have them marked, have them mapped. And then it's also a great idea to have 2 people that walk through this prior to gassing and know where these are. If something happens to a single person that has that information, it can be a catastrophe. And then the next is what is the capacity of the systems that are in place? And the next question is how long will ventilation take? And these two are very important in their relationship, right? Is the capacity of that structure you're treating, the ventilation capacity, enough to clear that in the time that you think that it should take or you're planning on it taking? And there's a formula for that we'll talk about as well. And then is there a risk to non-target areas? I know on some of the larger food processing operations and milling operations, even grain operations, I guess all fumigations, we take a look at an aerial view, sometimes a Google map of where it is we're treating and then where those non-target fence lines are and where will operators be, and are we comfortable with that? And if not, then we need to create some space, or we need to monitor those areas. So having that in your plan as well is crucial. Everyone should know right now, from a personal exposure standpoint, what the personal exposure levels are for the different fumigants. But if you're not familiar with it, I think it should be restated because this is going to be relative as we talk about ventilating. But for phosphine, the personal exposure level is 0.3 parts per million, and that comes with a time-weighted average. With methyl bromide and sulfuryl fluoride, they're both 1 part per million on a threshold limit value, which means that's it. There's no time weighting. There's no ifs, ands, or buts. It's a hard deck, not to exceed 1 part per million, unprotected. And so it's also important to note that these are U.S. EPA standards. So if you're listening from another country, it could be you could have different standards. Now, where this becomes important is when we're starting to think about the termination of the fumigation. What gas levels are we starting with? And there's a little confusion around this, I think, but it's important to have a clear understanding. With phosphine, the high range and the low range gas monitoring is the same. It's all parts per million. And so there's no confusion there, right? Now, with sulfuryl fluoride and methyl bromide, we're measuring that gas in ounces per 1,000 cubic feet. So how do you translate ounces per 1,000 cubic feet to parts per million? With sulfuryl fluoride, for every ounce you're reading on your monitor, on a high-range monitor, for every ounce, that's 240 parts per million. So if you've got 10 ounces at the end of the fumigation, when you start, you've got 2,400 parts per million. And that's quite a lift to reduce 2,400 ppm to zero, or less than one or less. And the same with methyl bromide. It's about 250 parts per million per ounce of gas suspended in the air. So it's important to understand what your terminal reading is when you start ventilation, and how that relates to where you need to be for gas-free clearance. Now, I'm going to show a table. I'm going to describe a table here, and that's calculating how to plan for how long it's going to take you to ventilate, and how, if you want to control that, what you need to do. And I refer to this as the dilution of 12. So essentially, most fumigants, when we start ventilation, are in a concentration range where we need to take the total volume that has been treated times 12, and that's the amount of air that we have to blow through that space, to get to a safe level. Now, there's some variability to this. And this principle is in concept something that we can use as a planning tool. It's not something we can use as a firm safety tool to determine clearance. I'm going to be super clear. I'm going to repeat this. We're trying to plan how long it's going to take to go from whatever concentration down to safe. And if we dilute that on average about 12 times, we're going to get there. So why this is important is it's going to help us understand if we know what our ventilation capacity is of a building, and you can find that out. Many times the site engineer knows what that is. Maintenance department might know what that is. If neither one of them can give you a good answer, we can explore and research it ourselves on the equipment that we're sealing, and start to calculate that in total, and come up with a pretty good estimate. So let's just kind of go into the formula. So if we take total cubic feet times 12 divided by time, and the numeric value that we're going to use on time is minutes, that will give us the total CFM needed to treat, or to clear that facility in the time that we want it to take. So I'm going to use a case example here of 100,000 cubic feet again. So 100,000 cubic feet times 12 equals 1.2 million cubic feet. Now, if you want to vent this in 4 hours, that's 240 minutes. So we take 1.2 million cubic feet divided by 240 minutes. That means we need 5,000 CFM of ventilation capacity. So if the 100,000 cubic foot structure, has 5,000 CFM of either supply air or ventilation capacity, then we can do that in 240 minutes. If we don't, we're going to have to bring in some supplemental ventilation to hit that 4-hour ventilation timeline. If you want that to be 8 hours, it's simple. You just double your minutes. If you want it to be shorter, you just divide it accordingly. So pretty simple formula. Again, it's not exact safety science. That's not the point of this. The point of this is crew planning, conforming to timelines that the customer and yourself have established. But you do have some control over this. And this is also where connected devices come into play too on the back end of the fumigation, because you can then monitor that degassing and watch it remotely. If anyone in here has ever had to kind of go back and forth in problematic ventilations and suit up with an SCBA and adjust fans or constantly take readings to observe problem areas, it gets exhausting. And to be able to observe this remotely is just another level of safety attribute and soft savings, soft benefits to connected devices. So I found this to be extremely important, especially for crew management. All right, we'd like to take a minute here. We're going to ask you guys to give us a like on your streaming platform. This is very important to us. It helps us quite a bit. So take a moment, hit that like button. Very much appreciate it. Tell other friend fumigators about All Things Fumigation and give us a hand promoting this if you would. Word of mouth is sometimes the most effective method of advertising. So also give us your feedback on this episode. We want to hear it. If you don't agree with something, that's how we can learn. It might be something that I add to the podcast next time. I'm not opposed to that. Again, that's how we learn. And then give us some suggestions for future programming. As you can see, as we started at these last 2 or 3 episodes with viewer questions and viewer comments, it's very helpful. Now, we're on ventilation and clearance, and we're going to break it down by post-harvest fumigation segment and characterization. And because they do differ widely, this is the one step in the fumigation process that has some real disparity in the approaches for ventilation in particular. So what we're talking about is containers, grain structures, grain holding, food processing, and then warehousing. So we're going to break these down a little bit, not in too much detail. We're going to go over some of the basics and then drive some tips and considerations for thought and hopefully safety improvement. The issue we spoke about a little earlier about ventilating land sea containers, these are an instance where many times there is a tremendous amount of consumed volume in these containers for logistics efficiencies. And it's dense material that has to be degassed. So, the prior principle of 12 does work with containers to a certain degree, but it's heavily influenced by what's diffusing, the gas that's diffusing out of this dense material. Passively, this is going to go very, very slowly. This is a place where active ventilation is worth the time and innovation to help facilitate that. And the interesting thing with containers is the amount of forced air, of ventilation system that's needed is relatively low. I know I used often the same type of blower we would use for recirculating closed loop systems for grain fumigation. We would use those same PB9 blowers to hook up to these containers, and we'll show you some innovative techniques in how we did that. But you're only needing 150 to 240 CFM to help facilitate that ventilation process. And if you're listening and not looking, I've got an example of an innovative device that a South American company came up with many years ago. You can actually create an opening in a locked container door. There's about an inch of variance there, and you can create a duct that's, I think ours are about 42, 44 inches long, that will connect to a 3-inch tube, connect to that PB9 blower, and then connect to a flange that reduces the volume and spreads it over linearly over about an inch. and you're able to fit that very thin ductwork in the doors and dog them tight and lock that door. And now you've got forced ventilation in that container. It's locked and secured. It's going to prevent reinfestation in some situations like DDGS and others. You've got some environments where reinfestation is a real threat. And you can also vent during bad weather as long as you're making sure that the blower's not sucking water in and forcing it into the container. So there's some consideration there, but that can be done, especially placing the blower under the chassis if there's a chassis. So this is a great way to hook these containers up and to move on to other tasks while they're degassing, quite frankly, much faster than just passive ventilation. Obviously, you're having to open the vents on the top corners of the container, but you're forcing supply air in and pushing that gas and that gas mixture out those container vents. So definitely a good way to do it if you've had some challenges with degassing. As a tip, I always push the issue of unsealing these vents when your fumigation is complete. When you've got statically dense material you're treating, which is almost all the time, you never really know how effective it's degassed. And leaving ventilation processes in place are critical. So removing seals from these vents must be done after the fumigation is complete, and obviously during ventilation and after ventilation. It's extremely important. Now, one thing I want to point out, and if you haven't noticed this, many of you might have, but some exporters, especially of electronic equipment coming into the U.S., moisture is an issue during voyage. The humid marine air, that they're surrounded by for up to 21 days sometimes, it intrudes on these containers and can damage packaging and electronics. So they'll put desiccant in there, and they'll also seal up these vents with clear tape. And they'll use various types of tape, but unfortunately, many times it's clear tape. And you may not notice it. Our mindset is when we are called to do a container fumigation, the container is already filled, so you may not be able to see inside there very well. But these vents must be unsealed, and really look closely for clear tape and remove that if it's in place. Now, I understand most containers are poorly sealed, right? Holding gas is our challenge with these. But there are some containers from time to time that are pretty tight. And you cannot assume that because these containers are thought to be poorly sealed, that there's not going to be a mishap or an issue. We've got to be responsible and diligent about our safety clearance, and this is just a simple step that'll help make sure that environment, that those breathing zones maintain safety. Now, the next one is grain, and grain is generally not an issue with ventilation. Their ventilation systems in these grain storages are designed to manage temperature and moisture, so they're extremely robust ventilation systems. They're usually all positive pressure with passive vents on the top, so they're pushing atmosphere through the interstitial space of the grain at very high volumes, and they're venting out the top. It's really ideal fumigation ventilation conditions. There are some instances where it's a negative pressure, where it's pulling out. You just have to kind of verify that. When it happens, it's pushing gas at chest level many times, where people and operators and even bystanders could have adulterated atmospheres. So you have to, again, as part of the recognition of what we're dealing with, that's an important one in the planning process. But generally, ventilation of grain is excellent. The systems are well designed. One consideration for grain systems, grain vessels, even even for food processing and milling operations, if there are small bins inside these treated spaces, anytime there's a confined space event after a fumigation, especially within the week or two or three, and that can vary. The confined space safety rule comes into place. So for confined spaces, generally we have equipment that's monitoring oxygen levels, lower explosive levels, and other gases, or depending on the situation. But the rule, the OSHA safety confined space rule, reads and any other possible contaminants. So we have to monitor for oxygen, we have to monitor for LELs, and any other possible contaminants. Well, fumigants now become that possible contaminant. And any confined space that we treat and that is in an area that we treated that now falls in that rule. So add that to your confined space entry program, or make sure your customer does. But they're going to require a lot of diligence around those potential entry points. And this is something when you're reviewing the FMP with your site management, you want to know if there's any post-treatment work that's going to take place that will require confined space entry. So the next segment is food processing operations, and these become quite a bit more dynamic in our ventilation and clearance approach. So most of the time, these are really compartmentalized structures. They have complicated ventilation systems, and then every facility seems to be very different. And then there's also considerations of variability in construction material. As many of you have experienced, many of these food processing facilities may have been originally built in the 50s, and they're block construction and can be very tight, but they can have loose features. Come into the 70s and steel, metal construction materials were used, which are very loose. And now we come into a modern era of slip form concrete, precast concrete that are very tight. So again, that's why characterization of these fumigations in planning is so important. Each one of these design features not only holds gas in varying degrees, they also ventilate in varying capacities. One of the things that I've found interesting over the years that for some reason has been difficult to communicate is we'll see HVAC systems on the roof. Some of these things are the size of a Winnebago. And right away, people conclude that this is going to vent very fast. Look how big that is. And quite frankly, some of these are 20, 40,000 CFM. But they only have a 10% air makeup. They're only allowing 10% of that capacity as fresh air intake. And that's a bit of a problem. So now it's not 20,000 CFM, it's 2,000 CFM. And sometimes these are fixed. Sometimes the year there's no air makeup and it's just looping and conditioning that air, either heating or cooling. So it's definitely something you want to talk to maintenance or an engineer about, get a good understanding for. But don't immediately assume just because you've got a lot of large air package units on the roof that it's going to vent fast. Now, the recirculation feature is going to help, right? It's going to help mix that air as you're supplying fresh air in during ventilation and exhausting fumigant out. It doesn't hurt anything, but it's definitely something you need to have a good grasp of. And then if you can envision a CAD diagram of a food processing facility with lots of interior rooms and hallways and corridors and product containment, it's critical that we're moving air, not just during the introduction of the gas, which is a label requirement of some fumigants, but also during the ventilation. That same fan usage helps us move air as we dilute it and pull gas out. So it really helps with that principle of 12 in ventilating. We really need to stir that air and blend it so that we're not getting fresh air channeling through that structure and pushing fresh air in and directly sucking, exhausting that same fresh air. We need to get it mixed. So another tip for helping ventilation, the ventilation stage, and this is a pretty big safety tip in my opinion as well, is prior to the fumigation, prior to gassing, and we mentioned it before, but want to mention it again in context, is open everything. Open bathrooms, offset ceiling tiles prior to the fumigation. Even non-target areas, like if an office is connected to the area you're fumigating, we're probably going to leak gas into some of those areas. We have to assume that we are. So open those offices up, put fans in there, blowing around. Get that set up in advance to ventilate, and that will greatly reduce the amount of time you have to go into an IDLH area to chase gas out of areas that can be, frankly, difficult to ventilate, as offices or some of those. So open everything that you can. Anything that you think you're going to monitor for clearance on the back end, make sure it's opened on the front end. Another challenge in food processing operations is refrigeration units and freezer units. Most of the time, we're not targeting these for fumigation, but gas does get in. They're tight, but they're not tight enough. Even attempts to seal these are generally futile, and gas gets in there, and then we've got to get them out. And just situationally, gases move more slowly when they're cold. The viscosity of the gas is thick and slow molecularly, and it's extremely difficult to get that moving. And there's also the integrity of the product in there. Generally, you're going to have to ventilate with warm air in an area where product is being conditioned for a reason. So these are conversations you want to have with your customer partner or your site management prior to the fumigation. Have an understanding of what needs to be done. If they understand the challenges, the safety challenges that surround this, can they move that product into reefer trailers and freezer trailers and open these doors and allow that to be part of the fumigation so that you can get it safely cleared? There are generally many options, but it's always better discussed well on the front end than before you show up on site. One other thing I'd like to add to that is your monitoring devices are generally set for a temperature sweet spot range. They're not as accurate. Accuracy can be thrown off when you walk from a 70 or 80 degree room into a 30 degree room or even a 40 degree room. So keep that in mind as well. And there are techniques that you can use to try to warm that gas sample. Like one of the things I would do is I would take a 350-foot spool, run one end into that cooler or freezer, run that spool outside, put it in the sun, and pull the sample, let it warm up through that coil. And that could get that gas sample back to a proper temperature range. All right, just another quick reminder to like us on your streaming network. Again, as we've said, it's important to us, and we greatly appreciate that, and definitely want your feedback. So I want to keep nudging you on that. Don't want to be too obnoxious, but it's very helpful. The last segment of the post-harvest ventilation consideration is warehouses. And we've talked about how, warehouses, some of the just massive warehousing operations that occur today. There's some people out there that say they can't be safely fumigated, and they absolutely can be and are. I've been associated with fumigations as big as 55 million cubic feet, and they were done safely and effectively. Ventilation, everything scales at these volumes. I always say these large 3PL warehouses, they're just a box. That's all they are. They're actually relatively easy to fumigate. They're not always easy to ventilate. It does require, really tight consideration on the ventilation side, and a lot of preparation. And we'll touch base on that. A lot of times there are some challenges with mixing the gas as we're venting because of the partitioning within these structures, because of the high racks. And there's also very large volumes of dense material. And that really prolongs the fumigation. Most of these facilities are extremely tight, like 120-hour half-loss times tight, believe it or not. And they are also electric deserts and ventilation bleak. So none of those are really great on the ventilation side. So they're just considerations and part of the planning process, but can be overcome and have been overcome successfully. But it really holds true. I'm showing a CAD diagram of a large warehouse. It's just a box like you can imagine. Unfortunately, many of them will have their loadout doors on one side, and the opposite side of that behemoth structure is just man doors. And that's where those portable ventilation doors come into place. I've run as many as 20 of those doors in a structure, and that comes out to be about 6 million cubic feet of fresh air being blown into a structure in it per hour. So it gives you some scale of how quickly you can bring in supplemental ventilation. But in this scheme, you've got air coming in the south end of this warehouse. You've got exhaust going out the north end of the warehouse. You've got some exhaust on the roof, but generally it's not enough to ventilate these alone in any reasonable amount of time. And this is also where interior circulation is absolutely critical. You've got to get a lot of extension cords and run those fans blowing upward, usually in the middle of that warehouse, and then also circulation counterclockwise or clockwise, but get that air inside that large space moving around and mixing very well. And again, extension cords are usually key, and sometimes supplemental power generation is key, but definitely can be done. There are usually dead areas in the corner, so you're running some gas through there. You have these kind of eddy areas, and it's generally the corners that are the problem. So also getting fans in those corners, large fans blowing up or blowing into that corner so that you're moving that dead air out into the ventilation flow. And here is another example of a fan door. These doors are portable. They're the size of a commercial door, right? So they're called a 3.0 door. And in this situation, we've got cutouts for farm fans to be placed in these. That fan will run about 5,000 CFM. And you've got room for two fans in there, so 10,000 CFM capacity. So you can ventilate a relatively large structure with setups like this. They're portable. They're adjustable. They can supply air in or be reversed and blow air out. They're very secure. There's brackets that are fit so that they'll conform to most any kind of door frame. And and one person can install this. It's not a major event putting these in and removing them. You do have to transport them and store them, but I found that we use these a lot because it would shorten the fumigation time, make us a lot more efficient, better asset use of time and labor costs. They were definitely an ROI for our business and really a professional way to solve some sometimes difficult ventilation challenges. And think about it, a lot of times these fumigations, we haven't treated these food processing structures before. So if we don't have history, we don't know where these ventilation traps are. And moving these around to mitigate gas concentrations has been very, very useful. Other tips that I wanted to point out in food processing operations is it's usually better to supply fresh air than exhaust. Both are best with a slight overpressure on the supply side is what I've found to expedite ventilation the most efficiently. During ventilation, there's sometimes a lot of downtime. Assigning other tasks during that ventilation process is pretty critical, and that's very subjective as well. There's a tendency for the team on site to want to start removing signs and things like that, but as you know, that can't be done until everything is safe in that structure, and those signs have to be visible. So if you've got doors that you're opening for whatever reason and propping open, and the warning sign is on the back side of that door and it can no longer be seen, you have to put up danger tape and move that warning sign so that it's very visible for somebody who may wander in. And I've had, not proud to say, but I've had more instances of my site point of contact showing up early to get the keys back and to do the walkthrough that think that they can just walk in. And if a sign is there, you're covered. If a sign is not there, you're not covered from a liability standpoint. So keep that in mind. One way to solve that, if you've got a lot of in and out in a door, is just to assign a safety person to that door and not letting anybody go in that's not monitored or unprotected. So that's a simple solution to a potential really risky issue. And then the buildings must stay secure during that ventilation. So if you're propping doors open and putting signs on there, what is your two levels of security? If the door is no longer locked, how are you handling making sure that somebody doesn't go into that building? So clearance does require diligence. We've got to monitor that dense material, and we've got to try to come up with a plan on how long it's going to take to degas. Sometimes, it's not a great idea to just start poking holes in product, but we can monitor inside the shrink wrap. We can monitor between pallets and between rows, and document that, on a pad of paper from your pocket, to just observe how that is degassing from that material. And that kind of helps us understand what the risks of contaminating the breathing zone. So very, very important to observe that process. And for me, I was always nervous. I mean, you never really know if a structure is gas-free. So only after diligent, detailed safety monitoring can you start to feel a little more comfortable. And on the gas-free documentation, we cannot make claim ever that 100% there's no way something could happen. And what the vernacular, the verbiage that I would always put on these documents, the gas-free document, is at the time of clearance, the structure was found to be below blank ppm and safe for reentry. And the reason I put that is I've had instances where we went and we told the customer to leave the ventilation system on. We've been diligent about our checks. I feel comfortable. I can leave now. But we want the ventilation systems to stay on just in case. just an extra level of assurance. And we turn the building over, we leave, maintenance comes in, our point of contact leaves, and they turn the ventilation systems off. It's just not a great idea, right? So leave those systems on, make it incredibly clear that they need to be left on. We used to hang signs on some of the control panels, the MCC panels, and things like that with instructions on not to turn off. So in summary, we'll wrap up episode 10 of All Things Fumigation here. Ventilation or venting, fumigation venting has a high safety risk. And we've got to recognize that as part of our planning process all the way through to execution. Ventilation and clearance requires intense planning. You can control how long venting takes. You can bring in supplemental ventilation and increase the speed at which we're clearing these buildings. And then I can't emphasize enough, check, double check, triple check safe levels before returning a facility back for reentry. And now you know why we named this episode Blow Like the Wind. Thank you very much for joining us for this episode. We greatly appreciate your viewership and listenership. And we want to remind you guys, be a science cowboy, apply the science, and protect your product. I am John B. Mueller, a fumigator by trade, and your guide to the science of fumigation done right.